Second unit concentrates on the actual implementation of security issues that are connected with the cryptography. That is, one is confidentiality. What are the components of the cryptography? One is the plain text. Along with this, in cryptography, we need another component, key. Why do you need a key? Hello students, welcome to the network security concept. I am Dr. Soumyashri from Department of Computer Science, Vidhyaashram College. In the last sessions, I finished the concepts in unit first, where the first unit is all about learning the basic things of the network security. Okay, why do we need network security? What are the different requirements of network security? What are the goals of network security? All those things, is it not? Let's move on to the next unit, that is second unit. Second unit concentrates on the actual implementation of security. How does the networks are going to secure the data that are passed on a network or passed on a network path. Okay. As I have said, there are two methods through which you can secure the data. One is cryptography, another one is steganography. Cryptography is all about changing the normal data so that it will not be able to recognized by the attacker. Another is steganography, hiding the original message in some other message. Okay. Steganography is not in the scope of our syllabus. Let us have a view about what is cryptography. How does cryptography can be implemented to secure the data over the network? Okay. As I said in the previous units, the word cryptography originally stands for the secret writing, cryptic writing, cryptic. That means secret writing which is not able to recognize. Okay. The term refers to the science and art of transforming the message to another form, original message to a non-recognizable form. Okay, which will become immune to attacks. Even if the attacker gets into the message, he will not be able to recognize what is it all about, what it is going to tell. Okay. Where are you can find the applications of cryptography is the ATM cards, computer passwords, they will be encrypted, and e-commerce, along with the messages sent in email, today's applications in operating system, all will be encrypted. That means others cannot be able to read your message or data. Okay. Cryptography, there are some of the issues that are connected with the cryptography. That is, one is confidentiality. Okay. It expects the cryptography is going to have the confidentiality. That means only the sender and the receiver will be able to recognize and read the message. Then endpoint authentication. The sender and receiver must identify each other before sending as well as receiving the message. Okay. There must be end-to-end authentication while passing on a message. Then message integrity. Okay. The cryptography ensures that message sent by the sender and received by the receiver will be in the same form without any transformation. The integrity of the message. Next, message non-repudiation. Message non-repudiation is refusing that the sender, refusing of the sender or sender refuses to recognize the message sent and the receiver refuses to receive the message, refuses that I have not received the message, which is called as the non-repudiation or refusal, repudiation or refusal. Okay. Then entity authentication. Okay, what is entity authentication? Is entity or identifying the user, okay, to access the system resources. For accessing a system resource, you need to identify the entity, like using maybe some passwords or thumb impression or facial expression or iris expression or iris print. So, anything can be used to authenticate an entity or an user to use a resource. Okay. So, these are the some of the expectations from the cryptography. Next, you need the components. What are the components of the cryptography? One is the plain text, another is the ciphertext. Okay. The original message before it gets transformed is called as the plain text. Before transforming it, it is called as the plain text. Once the message is transformed, change the original form, it is called as the ciphertext. It is not the original text, it is the ciphered text or transformed text, simply recognized as ciphertext. Okay. There will be certain algorithms which perform the encryption and decryption. Plain text, transforming the plain text to ciphertext will be done by the encryption. The process of transforming the plain text into ciphertext is called as the encryption, whereas transforming a ciphertext to plain text is called as a decryption. Decrypting, encrypting and decrypting. Okay. We will be having algorithms for doing these operations of encryption as well as the decryption. Okay. The encryption algorithm transforms the plain text to ciphertext, whereas a decryption algorithm will transform the ciphertext back into plain text. Okay. Here we have an example of plain text. We have this word hello. Hello can be transformed to another message by adding +3 alphabets to the H and creating the encrypted message. If it is hello, for each character in the hello, I will add extra 3 alphabets to create a new message. For H, I, J, K. K is the third alphabet from H. I will transform the H to K. Here we have E, F, G, H. H will be the third letter after E. E will be replaced by H. Okay. L, O is the third letter from L, third alphabet. So, I will replace L from O. Okay. Again, L will be replaced by O. O, R is the third letter alphabet from O, P, Q, R. R is the third alphabet. So, O will be replaced by R. Now, this text, if attacker is going to read this text, will not be able to recognize that the original message is hello. Okay. So, this is called as the plain text, whereas this is the cipher text, transformed text. Okay. So, cipher is the term that will be used to recognize a text. Okay. Cipher is the process of transforming original into the decrypted or transformed text. Okay. We'll use encryption and decryption algorithms which can be termed as ciphers. Algorithms are the ciphers which perform the encrypting as well as decrypting work. Their ciphers are also used to refer to different categories of algorithms which are used in cryptography. Apart from encryption and decryption, other types of algorithms are also used as ciphers. Any algorithm that are used in concept of cryptography are termed as the ciphers. Okay. There will be traditional substitutional ciphers, monoalphabetic cipher, polyalphabetic cipher. So, there will be two types, monoalphabetic and polyalphabetic. That means monoalphabetic means only one kind of transformation, like in previous example, hello was replaced by the third alphabets from the alphabets in the word. Okay. But in this hello, the letters or alphabets are randomly selected, which termed as polyalphabetic. Mono is single alphabetic cipher means single differentiation or single transformation of all the alphabets to another kind of alphabets. That means all the 5 alphabets in hello are transformed to third letter only. Here hello is transformed rapidly so that it can get any alphabet. H is replaced by A, E is replaced by B, L is replaced by N, whereas another L is replaced by Z. There both LL were replaced by O, the third alphabet from L. But here one L is having N, whereas another L is transformed into Z and O is transformed into F. There is no particular form or particular formula to convert the plain text to cipher text in case of polyalphabetic cipher. Okay. Along with this, in cryptography, we need another component, key. Why do you need a key? If there is no key, you cannot encrypt or decrypt the message back to the original form. To create or decrypt the data to original form, you need a key. If someone have locked your home, you need something to open it. You cannot open it as it is by the push of a hand, is it not? You need something to push it or open it. If they have used a key to lock the door, you need the same key to open it, is it not? If you don't have the key, you have to stand in front of the door until the person arrives who has locked the door. If you have key, you can open the door. If you have used a key to close it, you need the same key to open it, is it not? So, in the same way, in cryptography also, along with encryption and decryption, along with cipher algorithms, what you need is a key. Okay. Key may be a number or set of numbers, value or set of values. Anything you can take that the cipher operates as an algorithm. Whenever algorithm is executed, it creates a key, maybe a number or set of numbers, value or set of values. There may be single value or number or maybe set of multiple values. Okay. To encrypt a message, what you need is, you need an encryption algorithm, an encryption key and a plain text. What you need is a plain text, an encryption key and an encryption algorithm. What is the reverse process? To decrypt a message, we need a decryption algorithm to decrypt it, decryption key, again you need a key to open, and a cipher text. So, which reveals the original plain text. Okay. Encryption also needs 3 components. Decryption also needs 3 components. Encryption needs encryption algorithm, encryption key and plain text, whereas decryption needs decryption algorithm, decryption key and a cipher text. Alright. So, there will be different types of keys like shared key, public key and a private key. Why do we need public and private? We will learn as we move on to the next concept in the second unit. Okay, what is the use of key? Okay, if you have monoalphabetic cipher to encrypt the term hello, the key will be 3. That means you need to add 3 to the current number of h, the ASCII value of h. You need to add 3 to the ASCII value of h. You need to add 3 to the ASCII value of E. You need to add again 3 to the ASCII value of L. You need to add 3 to the ASCII value of O. Okay. So, this is a monoalphabetic cipher and uses the key 3. Here, key is a single number. Sometimes you may have set of values in a key. Okay. Now, you can have the ciphertext. To make it back to the hello, you need to subtract the ASCII value of k by 3, h by 3, o by 3, r by 3, which gives you the original message hello. Now, we have a diagrammatic representation of this process. Here, we have a sender Alice and a receiver Bob. Eve is a attacker or intruder who is trying to get to the message sent by the Alice to the Bob. Okay. So, there will be a plain text. There will be key by Alice, K1. Text, ciphertext will be moved on the network path. Bob will have a decryption key K2 which converts this ciphertext to the plain text. Okay. If M is termed as plain text, then ciphertext can be obtained by using the key K1 with the message M. Okay. Whereas M will be obtained, M is message will be obtained by applying key for the same message K1 of M. So, the same message again key will be applied which gives you the original message. Okay. Plain text M will be, key will be applied to the plain text which gives you the ciphertext, and to this K1M to decrypt it another key K2 will be applied. This gives you the M. Okay. We have in cryptography two types. One is the symmetric key, also called as the secret key cryptography algorithm. Another one is asymmetric key or public key cryptography algorithms. Symmetric key algorithms and asymmetric key algorithms. There will be two types. Okay. In symmetric key cryptography, the same key will be used by both the sender as well as the receiver. Same key will be used. Okay. The sender uses one key to encrypt the text using the encryption algorithm, and the receiver uses the same key to decrypt the text using the decryption algorithm. So, the thing is, if you have a K as key, this key will be used both by the sender and the receiver. Sender has to send this key along with the ciphertext, and receiver will receive the key and uses the key to transform the ciphertext to the plain text. Okay. So, this is how you can get explained. Okay. Alice uses the key K to change the plain text to ciphertext. Along with ciphertext, she shares the secret key. K will be shared, and Bob will receive the same key here, which can be used to convert the ciphertext to plain text. Okay. In this, if normal text is M, plain text, So, K can be used to generate a ciphertext. Same key will be applied again to the ciphertext to convert it to plain text, okay, in the expression form. In asymmetric key, there will be a change in the key. There will be two keys. One is a private key and a public key. What is the purpose of having private key and a public key is, private key is kept by the receiver, okay. Receiver will keep the private key, whereas public key is relieved or released to the public network path, okay. It will be available to anyone, okay, public key. Private key will be only received by the receiver. Nobody else will be able to access that private key. Suppose if the same Alice wants to send a message to Bob, what does the Alice uses is a public key. First, the sender will send the public key to encrypt the message. Okay. When the message is received by the Bob with the public key, the private key is used to decrypt the message. Public key available to everyone. If anyone access to the public key, he'll give the impression that, oh, I got a key to decrypt the message, but will not be able to decrypt the message because it was not the key that is used to open. But there will be another secret key, private key, which will be shared only with the receiver along with the ciphertext, which can be viewed and used only by the receiver. Okay. Some of the asymmetric algorithm can be used is Diffie-Hellman, RSA algorithm. So, we have these many algorithms which implement the concept of asymmetric key. Okay. Here we have the example diagram of asymmetric cryptography technique. Okay. Here Alice will use the private key, public key along with the ciphertext, which will be viewed by anyone. There will be a public key available to everybody. Okay. There will be a public key given to the Bob, which will be visible to everyone, but it cannot be used for decryption. There will be a private key K minus, okay. So, this will be to public. Even though they decrypt the message, the attacker will not be able to read the message. So, that is which is used for encryption, public key. Okay. Bob will have his own private key. He will use it for decryption, okay, which generates the plain text. Even though the Bob is having public key which has encrypted the message, if it is released to public, the public or the attacker will not be able to decrypt it. But the Bob will generate his own private key which can be used to decrypt the message. Alright. So, it can be expressed in a formula expression like this. If M is plain text, then ciphertext can be termed as K plus of M, and you can decrypt it using K minus. Private key you have to use. Alice used public key to encrypt it, but Bob used private key to decrypt it. Okay. So, this is an expression generated for the plain text to ciphertext and ciphertext to plain text. Alright. Now, we shall study about the symmetric key ciphers. We shall go for the asymmetric key in further sessions. Now, we shall concentrate on the traditional symmetric key ciphers. Okay. In traditional symmetric key ciphers, which is not currently used, okay, which is not much authenticated and much secure when compared to today's computers and attackers. They are much old-fashioned or old school. So what we'll do is, to know about the new kind of encryption, we need to study how does the traditional one works, because traditional one is the basis for the new one. So traditional symmetric key ciphers has three types. One is substitutional ciphers, transposition ciphers, and stream and block ciphers. Okay, let's study how does traditional ciphers will work. Okay, here we have the sender Alice. Here is the plain text. Okay, plain text will be using the encryption algorithm. Alice will be using the encryption algorithm to transform it to cipher text. Okay, so there will be a shared secret key which will be shared on a secure channel, not on the non-secured or insecure channel. On a secured channel, the secret key will be shared by the Alice to the Bob. But the Alice is going to share the cipher text on the insecure channel. She can send the cipher text on an insecure channel, but key will be exchanged only on the secured channel. Okay, when it comes to the Bob receiver, he will use the decryption algorithm to transform the cipher text to the plain text using the secret key. Since this is a symmetric key, we use the same key which was used by the Alice. Same key will be used by the Bob to decrypt the message. Okay, for both the sender and the receiver, same key will be used, where key will be shared only on the trusted channel, trusted network path, whereas cipher text can be transformed or transported over an insecure channel. Alice sends the message on the insecure channel, where, with the assumption that an attacker or an adversary cannot understand the contents of the message. Okay, to create cipher text uses the encryption algorithm, Alice. To create the plain text from the cipher text, the receiver Bob uses the decryption algorithm along with the same secret key. Okay, if you look at the procedure, the ciphers and the key are used set of values to operate on the original message. If you consider P as the plain text and C as the cipher text, P is the plain text, whereas C is the cipher text and K represents the key, then encryption algorithm can be represented as K of x. Okay, e to the e of x to the base k uses the same key k. E is the encryption algorithm, x is the message. Okay, then it creates the cipher text, and the decryption algorithm D can be represented as D of x, x is the message, with the key k. Here it is encryption algorithm, and you see decryption algorithm, which are used or which are represented using the e of x with the base k and d of x with the same base k, or the key k. Okay, which creates the plain text. Okay, these two algorithms work in a reverse order. What does the encryption do? Decryption algorithm will make the exact reverse of the encryption. Okay, this can be represented as C, that means cipher text will be generated by applying the encryption algorithm to the plain text. Okay, this C is applied to the reverse operation. Okay, so ciphertext, when decryption algorithm is used with the same key, the plain text will be used. So I can represent C equals E of K of P, and P can be obtained by applying D of K to the C. Ciphertext and original or plain text, both will work in a reverse order. Okay, here it has been shown D of K when applied to encryption. Okay, so if you implement encryption algorithm on X, if you again apply decryption algorithm on the same, you will get the original message. Suppose if you have decrypted first, so this will be totally different reverse operation. So it will be inversely equal to each other. Okay, encryption and decryption perform exactly the reverse operation of each other. All right. Here, Alice and Bob need another channel. Why do they need another channel? Is which is trusted, which exchange the secret key. Okay, they'll agree upon a secret key on single value key, which can be passed over a secure channel. That will be a face-to-face key exchange. There will be no message, nothing. Only key will be exchanged on a secured channel. Okay, you may have the question that even the data can be sent over a secured channel. Why not you can send over a secured channel? Is secured channel incurs more cost, needs more security measures. So it will be costlier when compared to the insecure channel. So only secret keys will be implemented for the decryption. Okay, there will be temporary keys that are used by both the encryption algorithm as well as the decryption algorithm. Okay, so they'll use the same key to encrypt as well as decrypt the message. Okay, so this is like locking a box and opening a box using the same key. Okay, this is about symmetric key, general symmetric key concept. So more about it will be learned with the next ciphers. In the next session, I am going to explain you about other types of symmetric key ciphers. So this is the general concept of symmetric key ciphers. Thank you.